Hey guys, this lesson is on solving polynomials by factoring. Now our steps are, the first one is going to be get everything equal to 0. So any variables, numbers that you have, you want on one side of the equals mark and 0 on the other. And preferably you want to put it in standard form there. Then you want to factor. And always remember that you're looking for a GCF first, because this could be any kind of factoring. This is why we went over the factoring completely notes. We want to be able to use any of our tools to factor. Then 3, we're going to set each piece equal to 0, and then we'll solve. So these will be little equations that we will solve to find out what x is. So here is our first example. We have 36x cubed minus x equals 0. So I'm first looking for a GCF, which I have as a x. And when I take that out, I just get 36x squared minus 1. Now 36 and 1 are both perfect squares, and x squared is a perfect square. And we have a minus. So this is a difference of perfect squares. So I want to factor this piece into 6x minus 1 and 6x plus 1. And now I have it fully factored. It's still set equal to 0. And I'm going to break those apart and set each piece equal to 0. And the reason we can do this is called the zero product property. It's saying that if you multiply things to get a 0, one of them has to be equal to 0. Or more could be equal to 0. But anyway, that's what allows that to happen. So we set the x equal to 0, the 6x minus 1 equal to 0, and the 6x plus 1 equal to 0. Now this one's already solved for us, so we are good to go. Here I'll need to add 1 to the other side and get 6x equals 1, and then I'll divide by 6. So it's covered up now, but you can see it will be x equals 1/6. On this third equation, I'm going to subtract 1 and then divide by 6, so I get a negative 1/6. So I have 3 answers there, and I should have 3 answers when the highest power, or my degree, is 3. Example 2. Now this is an example where we are not starting out equal to 0. So I'm going to need to add this 60x to the other side. So again, you want to make sure you do the opposite. Since it's a negative 60, I'm going to add it, so it'll be a positive 60 on the other side. And then I'm going to look for a GCF. In this case, that would be a 20x. When I take out that 20x, I get x squared plus 4x plus 3, which is our trinomial. So we are going to use the x factor. 3 will be in the top, 4 in the bottom, so you'll be asking what multiplies to get you 3 and adds to get you 4. And that will be 3 and 1. So we have a 20x outside, an x plus 3, and an x plus 1. We'll set each one of those equal to 0. So 20x will equal 0, x plus 3 will equal 0, and x plus 1 will equal 0. The first one I have to divide by 20, and 0 divided by any number, including 20, is 0. So 0 on top is okay, it is 0. In the second equation, I'm going to subtract 3, so I get x equals negative 3. And in the third equation, I'm going to subtract 1 and get x equals negative 1. So again, I have 3 answers. The degree of my problem was 3. I'm good. Example 3 is already set equal to 0. You could pause and try this one on your own. Okay, this is a trinomial, so we'll go into the x factor. I'm going to do the 3 times the negative 10 for the top and the negative 13 for the bottom and work that out. Now, I forgot to put my x over here for you, but it ends up to work out to 3x plus 2 and x minus 5. Now, if you didn't get this, go back and make sure that you divided by that 3 and reduced. So you would get to this point here. Then you would set each piece equal to 0, so 3x plus 2 will equal 0, and x minus 5 will equal 0. Here I'm going to subtract 2 and then divide by 3, so I get a negative 2/3. On the second one, I'm going to add 5, so I just get x equals 5. Example 4 is another one where we are not equal to 0. If you would like to pause, this would be a good one to pause and try. So I'm going to start, because it's not equal to 0, by subtracting the 48x, and I will get a 0 on the right hand side when I do that. And then again, I'm looking for a GCF. In this case, it'll be a 6x. That will leave me with x minus 8. This only leaves two things I need to set equal to 0. So I'm going to say 6x will equal 0 and x minus 8 will equal 0. Here I'm going to divide by 6. And again, when I divide, I get a 0. On this one, I'm going to add 8. So I just get x equals 8. So I have two answers, 0 and 8. The degree of my problem was 2. I know I have worked somewhat correctly here. All right, example 5 has a lot to it, but I need it to equal 0, so I'm going to subtract the 8x cubed and add the 125. And when I do that, I'm going to go ahead and put them in order. So I'm going to move that x cubed in the front because it should be the leading term, and the 125 in the back because it should be the plain number. But again, I need to subtract the 8x cubed and add the 125 so that I get it equal to 0. And again, I just went ahead and put it in standard form to work with it easier. Now, I'm always looking for a GCF, but I don't believe I have one here. So I'm going to go with factor by grouping because it has 4 terms. So I'm going to group the first two and the last two, and then I'm going to look for a GCF. So in the first set, my GCF is 4, but I have a mistake here. I was supposed to have a negative 8 when I subtracted this over. And so let me pause and fix that. Okay, so I'm going to back up and fix this for you. So I'm subtracting the 8x and adding the 125, just like I said I would. So this is a negative 8x out here. That's what I was missing a second ago. And that does make my GCF to be, for that first piece, a negative 4x cubed, and now everything makes sense. The second part, the GCF, was a 25. And then both parts that are left are 2x plus 5, which should always match. So I want to group the negative 4x squared plus 25 together and the 2x plus 5. And then I will set each one of those equal to 0. I will say that on this negative 4x squared plus 25, you'll notice all of those are perfect squares, but we didn't have a minus between them. But if you will switch those two things, which you are allowed to do, as long as you keep the signs of those things the same, in other words, the 25 is positive and the 4 is negative, then that is allowed. So I can switch that and it becomes a difference of perfect squares, which I can then separate. Okay, I just moved this to a new screen for you. I can then separate that with that perfect squares rule. So the 25 will be 5 and 5, the 4x squared will be 2x and 2x, 1 is a minus, 1 is a plus. I still have the 2x plus 5 on the end that I'm bringing down. Now I have three things to set equal to 0, 5 minus 2x, 5 plus 2x, and 2x plus 5. Now truthfully, these last two are the same and you'll see that they solve to be the same thing. On the first one, I'm going to add 2x to both sides and get 5 equals 2x. And then to get the x by itself, I'm going to divide by 2. So x is 5 halves. On the second one, ignore my computer please, I will subtract the 5, or excuse me, subtract the 2x. And again, I have made a mistake. So now I have that fixed. The 5 should equal the negative 2x, and divide by the negative 2, which gives us a negative 5 halves. And then for the last one, I'm going to subtract 5 and then divide by 2 and get the negative 5 halves. So these two did end up to be the same as they should have. And for example 6, I have another 4 terms, which looks like it's going to group well. So I'm going to group the first two and group the last two. And I have a GCF here of x squared, a GCF here of negative 4. When I take those out, both sets of parentheses are having the x plus 1. And then I can use my x squared minus 4 together and the x plus 1 written down one time. Then my first term is first binomial is a perfect square again with a minus, so it's a difference of perfect squares. I can factor that into x minus 2 and x plus 2. And then I'll set each of those terms equal to 0 and solve. So here I'm going to add 2 and get x equals 2, and I think it's covered up here. On the second one, I'll subtract 2 and get x equals negative 2. And then on the last one, I'm going to subtract 1 and get x equals negative 1. So that concludes this lesson, and again, the basic idea is factor completely as far as you can, and then set those final pieces equal to 0 and solve the equations.